Alright class, this is the worked out solutions to the pre-calculus final exam review. With the first problem, you're looking to find the total value, the exact value of that definite integral from 2 to 8. And unfortunately we don't know how to go from 2 to 8 right now, but we do know how to go from 0 to some value. So what we're going to do, as long as this is all staying positive and it's all symmetrical, which, well, in this particular problem it's not, but that's not going to be that big of a deal. What we can do is break it down to say it's the integral from 0 to 8 minus the integral from 0 to 2. So those are the two values that we're really going to be concerned about. In this particular problem, we can pretend that we're going to use our quadratic model, where we would have a c sub 2 value, which in this case there is no x squared term, so we call that 0. C sub 1 value, which we know is at 1/4, and a c sub 0 value, which is that constant term 6. And if we want to integrate with respect to x, we're going to say this is the c sub 2 value 0 times by the upper boundary a cubed divided by 3 plus the c sub 1 value, which is 1/4, times by the upper boundary a squared divided by 2 plus 6 right here, the coefficient of the constant term, times by the upper boundary a. So if we take this back over to how we broke our integral up into two parts, we can say the upper boundary in the first half is 8 and the upper boundary in the second half is 2. So if we integrate the first part with 8, what we can do is take, well, actually going back to this right here, 0 times anything is 0, so this whole term kind of cancels out. It's not really needed. So if a is 8 to begin with, what we can do is say this is 1/4 times by 8 squared divided by 2 plus 6 times by 8 minus, now we're going to subtract the second integral. We'll say, I'll put it all in parentheses so you know to add them all together first, and then you can subtract just one value. 1/4 times by 2, now a is 2, squared divided by 2 plus 6 times 2. So if I clean all this up and multiply 8 squared, we're going to say 64. 64 divided by 2 is 32, and 1/4 times 32, well, that's all going to give you 8 right there, plus 6 times 8, that'll give you 48, minus, so in parentheses here you got 2 squared, which will be 4. 4 divided by 2 is 2. 1/4 times 2 is a half, so 0.5 or 5/10, plus 2 times 6 is going to be 12. So you combine your terms here and you have 8 plus 48 is 56, minus a half plus 12 is 12.5. You do a little subtraction problem and you end up with 43.5, or 43 and 5/10. So there you go, you got that one right. Great, moving on. Taking a look now at number 2. Number 2, you're asked to find the sixth term in the sequence, and it's a recursive sequence. So recursive basically means you can't find the next term unless you know the exact previous term. And they define the first term, which is 2, and the second term, which is 4, and the next term is 3 times the previous term plus the term right before that. So that's why they gave us 2 terms instead of just 1. So if we wanted to find out the third term, a sub 3, we could say it's equal to 3 times the one right before that, a sub 2, which is 4, plus, so times right there, 3 times 4 plus the term right before that, which was a sub 1 or 2. So that means 3 times 4 plus 2 more, that's going to be a grand total of 14. Alright, so a sub 4 now, we can say is 3 times by the term right before that, so now we're on a sub 3, which was 14, plus the term before that was a sub 2, which was 4. So you combine those guys, 3 times 14 plus 4 more, that'll give you 46. Okay, so we're going to go with a sub 5. which would be 3 times a sub 4, 46, plus a sub 3, 14, which will give you 152. And now we're going to go to a sub 6. A sub 6 is what we're trying to figure out, the sixth term. You're going to be 3 times by a sub 5, 152, plus a sub 4, 46, which gives you 502. So right there, 502 is a sub 6. Okay, let's take a look at number 3. Number 3, find the smallest positive integer solution for x to the following 173 logically equivalent to x mod 4. Modular math, a lot of people get a little scared of it, but it's really nothing more than a division problem. So 173 mod 4 just means every 4 values they repeat. So what you really do is some old style division. You take 4 and you divide it into 173. You want to figure out how many times does 4 go into 173, and you could realize it's going to be 43. But it's not 43 on the nose, there's some remainder left over, and that remainder is 1. Well, that means you can go 43 times around in groups of 4 with just one little number left over. So that x value is actually going to be 1. The remainder is what that smallest integer could be. There's other answers that this could be. X could also be 5, x could also be 9, anything that would have a remainder of 1 when you divide with 4, but the smallest positive integer would be 1. So that's the one we're looking at for that one. On number 4, solve for x if you have 3/4 times x to the 3/4 is equal to 6. So a little bit of an algebra problem here. What I would do is get rid of this first 3/4. The coefficient's 3/4, opposite of multiply by 3/4. A lot of people say divide by 3/4, but I would count that as multiply by the reciprocal of 4/3. So if you do that, you can multiply both sides by 4/3. So this would be x to the 3/4 is equal to 6 times by 4/3. So that cancels out your 3/4 on the left side of the equation. And then you can say 6 times 4/3, well, that'll be 8. So x to the 3/4 is equal to 8. And then from here, to get rid of this 3/4, you want to really make this exponent 1, because x to the first is x, which is what we're going to try to solve for. And if we want to get rid of this 4/3, you can raise both sides of your equation to any exponent you want to, as long as it's the same. And the best thing to do that would be to raise it to its reciprocal again, 4/3. So we'd have to raise this guy to the 4/3. So x to the 3/4 to the 4/3 is actually x to the 12/12, which is x to the first, which is just x. 8 to the 4/3, well, if the 3 is in the denominator, that means take the root of that. So take the cube root of 8. Cube root of 8 is 2. 2 to the 4th power is 16. So 8 to the 4/3 is the same thing as 16. X is 16 in this problem. And we're going to number 5. Given that f prime of x is equal to x minus 2 squared minus 9, at what value of x will f of x have a relative minimum? So in this particular problem, they're comparing a derivative with the function. They don't tell you what the function actually is, and you don't really need to know that. But you do know that you have a derivative here. And one of the nice things about the derivative is if you let the derivative equal 0, so f prime of x is equal to 0, you have either a relative minimum or a relative maximum, or you have some type of tangent line slope is going to be 0. So that's what we're looking for, where the derivative is 0. So we set f prime of x equal to 0, so this is x minus 2 squared minus 9 is going to be equal to 0. So we can go through and we can solve this by adding 9 to both sides and say 9 is equal to x minus 2 squared. We can take the square root of both sides and say plus or minus 3 is equal to x minus 2. And then we can add 2 to both sides and we can say x is either equal to negative 1 or positive 5. So if you checked your answers already online, you would have found out that the actual answer is 5 and not negative 1, but you might be wondering, why is it 5 and not negative 1? Why is it only 5? And the rest of this problem is actually with testing it, because they ask you for a relative minimum, not a relative minimum or maximum. So what we're going to do is look at the test point method. And with that test point method, if you guys remember, you draw a little number line and you plot your zeros. So we have a 5 somewhere over here, we've got a negative 1 somewhere over there, and we know that those are the zeros, so that's either going to be minimums or maximums. What we do with this is we pick 3 points in those 3 sections that we've divided our little number line into. Something smaller than negative 1, something between negative 1 and 5, and something larger than 5. And whatever the value is, positive or negative, between any of those values, all of the numbers in those sections will be that value, positive or negative. So we pick a value that's smaller than negative 1. For example, we might test negative 2. So if we test negative 2 and we substitute negative 2 into the back into the derivative here, we substitute it in and we get, let's see here, negative 2 minus 2 is negative 4, negative 4 squared positive 16, positive 16 minus 9, well, that'll give you a positive answer. So everything in this value is positive from anything smaller than negative 1. Between negative 1 and 5, we might want to test the point 0. So we test the point 0, we substitute that back in, we'd say 0 minus 2, negative 2 squared is going to be 4, 4 minus 9 is going to be a negative value. So everything between negative 1 and 5 is negative. Alright, and then from here, 5 and up, you might want to test the point, I don't know, an easier point might be 6. So you test out point 6, 6 minus 2 is 4, 4 squared 16, 16 minus 9 is going to be a positive answer. So everything 5 and up is positive. So this tells us that the graph of f of x has positive slopes to negative 1, then negative slopes to positive 5, and then positive slopes up. So if we sketch a rough graph as to what that would look like. So you know negative 1 and 5 are going to be slopes of 0. So it has positive slopes to negative 1. It has negative slopes to positive 5. And then it has positive slopes again back up forever. So the graph looks like it might be some type of cubic. So it might look something like this. Negative 1, positive 5, where it goes up and then down and then back up. Something like that. It might not, but bottom line is this right here is a maximum, a relative maximum, and this right here is a relative minimum. You're looking for a relative minimum, not a relative maximum. That's why we select 5 and not negative 1. Alright, let's move on to number 6 now. Number 6, f of x is negative 3x squared plus 18x. What's the value of f? So in this particular problem, I think I actually made a little typo here. What's the maximum value of f is what we're trying to figure out. So if we want to try to figure out the maximum value of f, we could graph this, or we could use the derivative method. So if you were trying to find the derivative, f prime of x, at negative 3x squared plus 18x, remember the rule, you take that exponent, you make it the coefficient, multiply it with that coefficient, decrease the exponent by 1. So negative 3 times 2 is going to be a negative 6, back the exponent off by 1, and you just get plain old x. Alright, the exponent there for 18x is 1, move it down with the 18, so 18 times 1 is 18, back the exponent off by 1, so x to the first becomes x to the 0, so it's just negative 6x plus 18. So from here, if we want a maximum value, we're going to say f prime of x is going to all be equal to 0. So the derivative is going to be 0. So this means 0 is equal to negative 6x plus 18. And we can subtract 18, divide by negative 6, and say x is actually equal to a positive 3. So the maximum value of f occurs at x equals 3. So what is that maximum value of f? Well, you substitute that 3 back into the equation, and you can say f of 3 is equal to negative 3 times 3 squared plus 18 times 3. So negative 3 times 3 squared plus 18 times 3 is going to be a grand total of 27. So your answer, ordered pair 327, but the true maximum value of f is 27. So others might say 27 at x equals 3, but the maximum is 27. Moving on to number 7 now. Solve the inequality x squared minus 3x minus 4 is greater than or equal to 0. I know it's your favorite thing to do, and it's factoring. So we're trying to think two numbers multiply negative 4, but it'll add up to be negative 3. That's a negative 4 and a positive 1. So if we factor this, we can say this is x minus 4 times by x plus 1 is greater than or equal to 0. So from here, we're going to go back to the test point method and say your zeros are x is equal to positive 4 and x is equal to negative 1. So with that test point method, you might want to draw out your number line, and you might want to plot those points of negative 1 somewhere over there, 4 somewhere over there. You split this up into those 3 sections like we did before, and you want to pick a point in each part. So we might say over here you're going to test out negative 2, and substitute in and see if the value is true or false. If you test in negative 2, you have negative 2 minus 4 is a negative, and then negative 2 plus 1 is still a negative. A negative times a negative is a positive, which makes this true. So this is a yes. So this part should be shaded. So I'm just going to jot myself a little note here and just say yes to this part because it's true, it's in the solution set. Over here we might want to test out 0. It's in between negative 1 and 4. So we test out 0 minus 4 is a negative. 0 plus 1 is a positive. Negative times a positive is a negative. This right here, it says it has to be greater than or equal to 0. So it has to be positive. Our answer is a negative. So this part right here is not in the solution set. And then the last part right here, you might want to test out something bigger than 4. I'm going to test out 5. So 5 minus 4 is positive. 5 plus 1 is positive. Positive times positive is positive. And positive is true. So we'll say yes on that one as well. That should be in the solution set. So your final answer, what we'll do is we'll say it's got to be anything that's negative 1 or smaller and anything that's 4 or larger. So on a number line, if you were to graph that, you would throw in a negative 1, you would throw in a positive 4, you might want to put 0 as an indicator. Close circles on negative 1 and positive 4 because it can be equal to, and we would shade in opposite directions like that and like that. In interval notation, you say the smallest possible value would be negative infinity. We're going to go all the way up to negative 1. We'll put a bracket because we do include it. We'll union that with, skip a few up to 4 inclusive, all the way to positive infinity. So there you have it. We move on to number 8. Convert the polar coordinates to rectangular coordinates. So the rule for conversion here, you're going to say x is equal to r times by the cosine of theta, and y is equal to the r value times by the cosine, just kidding, not the cosine. That would be the sine of theta. So that's the two conversion rules. So if we have an r value of 3 and a theta value of 45 degrees, we can substitute and say x is equal to 3 times the cosine of 45 degrees, and y is equal to 3 times by the sine of 45 degrees. One of the nice things about this is you should have those values already memorized from the unit circle. The cosine of 45 is just root 2 over 2, so x is equal to 3 times the square root of 2 over 2, and the same exact thing holds true for the y value, 3 times the square root of 2 over 2. So to rectangular coordinates, you got an x, you got a y, write it as an ordered pair. 3 root 2 over 2 and 3 root 2 over 2. If you used your calculator because you forgot about the square root of 2 over 2, you might end up with a solution of 2.12 and 2.12, and technically that's a rounded answer, which, I mean, it's in the ballpark. It's okay for now, but on your final exam you might realize that that's not a choice. This is a better answer, so just be aware of that. But this is still in the calculator section. So moving on to number 9. Toy rockets launched from a 3-foot platform. So the height of the rocket h in feet depends on the time t in seconds, and it's given by that equation. We're looking for instantaneous velocity. So the first thing right there, instantaneous velocity, that's the key word to help you find the derivative. So that's what we're looking for in number 9, is the derivative. So first of all, if you have that right there, that h of t equation, you can find the derivative h prime of t just by using your derivative rules, and say this will be negative 32t plus 75, and that plus 3 just kind of disappears. So we want to find instantaneous velocity at 1 second. So we want to find the derivative at a time value of 1. So that's negative 32 times 1 plus 75, which ends up being a negative 32 plus the 75, which is 43 feet per second. Instantaneous velocity right there. If we move on to number 10. So there's a complex number z which is equal to 2 plus I. Convert it to rectangular, polar, and trig forms, and we're going to figure out the values of z squared, z cubed, and so on and so on. Then we're going to graph them. So first part A, let's convert it to rectangular first of all. That should be pretty easy. If it's 2 plus I, rectangular coordinates are 2, 1. Done. Pretty basic right there. That right there would be the x. Whatever the coefficient is to the I is the y value. Alright, so polar form. Polar it takes a little bit more work now, so you got to find a radius which is equal to the square root of x squared plus y squared. And you need to find a theta, where you want to take the inverse tangent of y over x, and just be careful to check for the quadrant. So to find the radius, first of all, you're going to take the square root of 2 squared plus 1 squared, which is just the square root of 5. And to find the theta value, you take the inverse tangent of y over x, which would be 1 over 2, so the inverse tangent of 1/2, and that's not a very nice number that we know, so we can use our calculator and we will round that to, we'll say, about 26.57 degrees. So in polar form, you can put down the brackets there of the square root of 5 and 26.57 degrees. Alright, last one is trig form. So trig form, once you have polar form, trig form's a little bit easier to work with, where you just really want to take the radius, which was the square root of 5, and you're going to multiply it by the cosine of the angle 26.57 degrees plus I times the sine of 26.57 degrees. So that's all a trig form is. Trig form's a little bit of a bridge to go from the polar form back to the rectangular form. So it's a conversion bridge right there. So that's all part A. Part B is the next value that we want, and that's z squared, z cubed, and z to the 4th. To do those guys, you might remember de Moivre's theorem, and that's saying that what you want to do, for example, with z squared is you want to take the radius and square it, and take the exponent 2 and multiply it by your theta. So this is saying then z squared would be the square root of 5 squared, which is 5, and 2 times theta, well, that would be 26.57 times 2, which is 53.14. We have a 53.14 degrees. So z cubed, same process, except now we want to, instead of having r squared, it's r cubed. Instead of 2 times theta, it's 3 times theta. So we take the square root of 5 raised to the third power, and we can say that's just the square root of 5 raised to the third power. And 26.57 times 3, that's going to be 79.71 degrees. And then we say z to the fourth is the square root of 5 raised to the fourth, and that's 25. And then 4 times by theta, which would end up being 106.28 degrees. So there's de Moivre's theorem with part B. Now part C, what we're going to do is plot these 3 points, actually 4 points, because they also wanted z. So here's a smaller polar grid, and it doesn't have what I'm going to count by, so I'm just going to pretend to count by, I'll count by 5. So we got 5, 10, 15, 20, and then we'll pretend that 25 is right there on the ends. So the first one I want is the square root of 5, which is about 2.24, so almost in the middle of the two. And I want my angle to be 26.57, so just a smidge under 30 degrees, so I don't know, somewhere about there. Right there in orange would be z. Then I want z squared, which is 5, so I'm actually going to go on the 5 circle, and I want to go up to 53.14 degrees, so in between the 45 and the 60 angle markings right there. And then I'm going to go the square root of 5 cubed, and that's about 11.8. So that's 5, that's 10, so a little bit beyond the 10 circle. And I want my angle to be 79.71, so that's somewhere between the 60 and the 90 angle marking right there. So somewhere right around there. Kind of a big point, but you kind of get the idea of that. And the last one would be 25, which is way out there, and then 106.28. So 106.28 we'll say is, well, it would be 90, so that would be 120. So somewhere in between the 90 and the 120, so somewhere up there. So it's a rough sketch on this, but if you were to continue plotting these, you'd end up with a spiral, and it would get really large really fast. So that's number 10 there. On number 11, so first up, f of x is 3/2 x squared. There's a graph right away for you. So that's one thing to kind of pay attention to. That's one of the graphs right there that we have. 0 is right there, and I already put 4, so we're going to count by 1s down here. So it's asking us now for part B to draw the Riemann rectangles. One width is the right side. So the width is 1, and we want the right side. So if we want the right side, these are the right end points. So I'm going to go up to the line. I'm going to kind of draw it over like that. So kind of one rectangle. My second rectangle, I'm going to go up here to the right end point, come over, and I can draw it back down. My third rectangle, I come up to the curve, I go back over, and I come down. And then the last one, I'm going to draw it straight up to the curve, and then I'm going to bring it over and bring it down. So kind of like your cell phone bars right there. More bars in more places. And what we're going to do is determine the sum of the area of the Riemann rectangles. So in all of these, the width is 1. That's nice to know. And the height is something else that we want to calculate. And with these height values, what you want to do is realize that if you have an x value of 1, 2, 3, and 4, you have to find the y values. And you can do that just by substituting 1, 2, 3, 4 into your equation, because you have one. You have 1 squared times 3 halves is just going to be 3 halves. So we might say 3 halves for this one. I'll put it down here. And for this one right here, 2, substitute 2 in there. 2 squared is 4. 4 times 3 halves is going to be 6. So that height's 6. Over here is 3. Substitute 3. 3 squared is 9. 9 times 3 halves, well, that'll be 13.5. And then 4. 4 squared, 16. 16 times 3 halves is 24. So there we have our heights. What we can do is take the width, which is 1, multiply it by the sum of all the heights. 3 halves are 1.5, plus 6, plus 13.5, plus 24. Now since the width was only 1, that's not going to have too much of a factor of it, but when you multiply them all out, add them together, you end up with a grand total of 45. Alright, part, let's see here, we got B, which was the Riemann rectangles. I guess this is part C, determine the sum of the area of the rectangles. And then part D, then, we're going to use integration. So if we use integration to find the area under the curve, we're actually going to take the integral from 0 to 4 of your function 3 halves x squared, and then with respect to x. So if we do this, there's no c sub 1 value and no c sub 0 value, it's just a c sub 2. So that makes it a little bit easier with that, where we can say this is then 3 halves times by 4 cubed over 3. So when you calculate all that, you end up with 32, which would be the exact area. So 32 would be the exact value of that integral. 45 was our estimate. It's a little bit larger, and you can see that we have these extra sections right here, which we really don't need, which are just excess that we kind of got rid of when we found the integral. So that's number 11, and that kind of ends our problems with the calculator. So now we're going to go to non-calculator part. Alright, going to the non-calculator part on number 12. So we're going to figure out the summation as k goes from 1 to 4 of k squared plus 2k minus 5. So first thing what you want to do is might try to figure out what all these partial values are. So if k is 1, you substitute 1 in there, you got 1 squared plus 2 times 1 minus 5, you end up with negative 2. If the k value is 2, you substitute that 2 in there, 2 squared plus 2 times 2 minus 5 is going to be a grand total of 3. If the k value is 3, you substitute that in there, 3 squared plus 2 times 3 minus 5, and you get 10. And if k is 4, substitute 4 in, 4 squared plus 2 times 4 minus 5, you get the 19. If you want the summation, that means add, so you add all those guys together. Negative 2 plus 3. Well, if you think about it this way, just negative 2 plus 3, that's 1. That would be the summation as k goes from 1 to 4. So if you want to figure out the summation as k, or I'm sorry, from 1 to 2. If you want to figure out the summation as k goes from 1 to 3, you take the summation from 1 to 2 and add the 3, so that should be 1 plus 10, which is at 11. And you take the 11 plus that fourth value of 19, and that's where we get our 30 from. So a nice little summation problem, no calculator necessary. Number 13, what's the value of x if 3 over x plus 1 plus 3 over x is equal to 8 over x? So with these types of problems, what you might need to do is get some type of common denominator to help you out with the numerators. So if I see an x plus 1 and an x, the common denominator, I'll just have to multiply the fractions that have the denominator of x by an x plus 1, and the fractions that have a denominator of x plus 1 by a value of x. So I'm going to take x over x times by 3 over x plus 1 plus, now I need the x plus 1 idea, x plus 1 over x plus 1 times by 3 over x is equal to, and we've got an 8, and then the denominator is x, so I need the x plus 1, so this will be x plus 1 over x plus 1 times by 8 over x. So now you can see all three of these denominators will be x plus 1 times x. So what I can say here is this is 3x over x times x plus 1 plus, if I distribute that 3 out, I'm going to say this is 3x plus 3 over x times x plus 1 is equal to, if I distribute that 8, this is 8x plus 8 over x times x plus 1. So now since I have common denominators on this left side, I can combine my two fractions. 3x plus 3x plus 3 is actually 6x plus 3 over x times x plus 1, which is equal to 8x plus 8 over x times x plus 1. One of the neat rules about math is that if you have denominators that are equal, which we do, we should have numerators that are equal. Well, they don't look very equal, but we can make them equal. So what we'll say is then 6x plus 3 equals 8x plus 8. And from here, if you kind of get all your x's on the same side, swing everything else onto the other side, we'll end up with x being equal to negative 5 over 2. One little issue with these types of problems is look for your restrictions. So if you go back to the original problem, they said that 3 over x plus 1, you cannot divide by 0. So 0 is bad. So x plus 1 can't be 0, which means x can't be negative 1. Over here you can't divide by 0, so it's just 3 over x, so that means x can't be 0. And the last thing is 8 over x, so x can't be 0 again. So those are your two restrictions. X can't be negative 1, and x can't be 0. If your answer happened to be anything that's a restriction, you have to exclude it. But it's not this time, so negative 5 halves is what we're focused on. Number 14. So you have a velocity right here of an object, and it's t seconds is t squared minus 4t plus 3. You're looking for the total distance traveled. So this is an integral problem. So if we write it out as an integral, we can say it's the integral from 0 to 4 of the function t squared minus 4t plus 3. And this is with respect to t this time, not x, because t is our variable. So the distance that we're looking for, so if we can integrate this and use our a value of 4, we'll be in good shape. So what we'll say is this is 1 times 4/3 over 3. And this would be minus 4, because that's the coefficient there of the t term, times by 4 squared over 2, where 4 is the upper limit, plus 3 times 4. So when you multiply all these guys out, you end up with 64 over 3 minus the 32 plus the 12, which you combine everything out, and it actually ends up being 4/3 of a foot. So that's what we wanted there. I'm moving on there to number 15. So if z is at number 2 plus 5i, we're trying to find out z times by z bar. You guys might remember z bar, that comical name there, z bar, which is the complex conjugate. So first thing we want to do is realize that z bar is 2 minus 5i. So if z is 2 plus 5i and z bar is 2 minus 5i, we can take 2 plus 5i, multiply it with 2 minus 5i, and this is just a FOIL type problem. 2 times 2 is 4, 2 times negative 5i is negative 10i, 5i and 2i is positive 10i, and 5i, negative 5i, that's a negative 25i squared. So combining your like terms, your negative 10, positive 10 cancel out. I squared is negative 1 times a negative 25 is a positive 25. So we have 4 plus 25, which is a 29. So that's what we get when we multiply z with its complex conjugate, z bar. If we go on to number 16. 16, it asks for the exact value of the sine 2x, and cosine x is 8/17. So one little rule that we have, you might see this still in your formula sheet if you forgot what it was, the double angle theorem, which is actually equal to 2 times by the sine of the angle times by the cosine of the angle. And we don't really know what the angle is, but we do know that the cosine of x is equal to 8/17. So what we can do is take, well, let's see here, the cosine of x is 8/17. So cosine of x is 8/17. That's that part right there. If we can find out what the sine of x is, we'll be in good shape, because we just have to multiply it by 8/17 and by 2, and then that's what we're trying to solve for. So we need to figure out what is the sine of x. And you might remember your Pythagorean identity, and that says that sine squared plus cosine squared equals that magic number 1. Well, we have cosine, which is 8/17, so sine squared plus 8/17 squared equals 1. So that means that sine squared is equal to 64 over 289. Wait a second. Sine squared plus 64 over 289 equals 1. So you can subtract the 64 over 289 from 1 to both sides, and we can say that sine squared is actually equal to 225 over 289, which means the sine value, if you take the square root of those guys, would be 15 over 17. So that nice little review if you forgot about that from trig. So now we know what the sine value is of x is 15 over 17. So you substitute back into the problem, and we can take the sine of 2x, which is equal to 2 times by 15/17, which is the sine of x, times by 8/17, which is the cosine of x, which ends up being 2, 15, 8, 17, 17, and 1. Multiply those guys together, 240 over 289. So a little bit of work, a little bit of trig review for that one. If we look at number 17, write the series in summation notation. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. That base is the thing that's changing. The power stays as 2. The exponent up there stays as 2. So we're going to take the summation, because it's asked for a summation. And you can use whatever variable you want to. Sometimes you see an I. I'm going to use a k. So as k starts at 1 and stops at 7, and k is that base number, so we'll say k. So the summation is k goes from 1 to 7 of k, and that value is always squared. So this would be 1 squared plus 2 squared plus 3 squared all the way up to 7 squared. So that's what we have with that one. Pretty straightforward. Number 18, we have a multiple choice problem. What statement's equivalent to not P or Q? And this is De Morgan's law, if you remember that. It's kind of like distributing the negation, but when you do that, you got to switch that or to an and. So it will be not P and not Q. So not P and not Q, that looks like B. Alright, if we look at number 19, what's the value of the definite integral from 1 to 5 of x squared plus 2 with respect to x? So we're going to break this up to be the integral from 0 to 5 minus the integral from 0 to 1. Alright, so if we're going to do that, we got to integrate this guy twice. And the first time we're going to say this is 5 cubed over 3 plus 2 times 5 minus, we'll say 1 cubed over 3 plus 2 times 1. So little integration rules, that should be pretty fresh in your mind. You combine this side, 5 cubed over 3 plus 2 times 5, you get 155 over 3 minus, you combine what's inside of parentheses, 1 cubed over 3 plus 2 times 1, that'll be 7/3. And when you take 155 minus 7, you get 148 over 3. So there's your exact value, your definite integral. Number 20, what's the remainder? So polynomial division. So x plus 1 is going to go into, take a 4x squared minus a 3x plus a 4. So in your mind you're thinking what times x is 4x squared, and that should be a 4x. So 4x times x, that's a 4x squared. 4x times 1, that's a positive 4x. You take the whole top, subtract the whole bottom, and 4x squared minus 4x squared cancels out. It always should. 3x minus 4x turns into a negative 7x. I always like to write it this way in parentheses so I remember to subtract top minus bottom. Sometimes we lose our focus on whether these guys should be positives or negatives. And then we can bring on down the 4. So we go again. What times x is negative 7x? That's what you're thinking, and you're going to say, oh, that's a negative 7x, or just a negative 7. Negative 7 times x is a negative 7x, and a negative 7 times 1 is a negative 7. You subtract top minus bottom. The negative 7x minus negative 7x cancels out. They always should. And then 4 minus negative 7 is a positive 11. If you want to try to go again, what times x is 11? It doesn't work all that well, so we're done. We're finished. And that's your remainder of 11. So it asks what the remainder is. You can say the remainder is 11. Number 21. Find the equation of the oblique asymptote of the function f of x is equal to 6x squared minus 7x plus 12 over 3x minus 2. So an oblique asymptote, meaning after you do the division, what function are you left over with? So from number 20, we're actually going to do the division again. 3x minus 2 goes into 6x squared minus 7x plus 12. So what times 3x is 6x squared? That would be 2x. 2x times 3x is 6x squared. 2x times a negative 2 is a negative 4x. You can take top minus bottom and subtract. 6x squared cancel out. Negative 7x minus the negative 4x. Well, that'll end up being a negative 3x plus a 12. What times 3x is negative 3x? That's a minus 1. Minus 1 times 3x is a negative 3x. And a minus 1 times a negative 2 is a positive 2. So we're going to subtract top minus bottom. Negative 3x's drop out. And 12 minus 2 is a 10. So we have 2x minus 1 with a remainder of 10. But in this particular problem, they're asking for the oblique asymptote, which is the division problem. So the oblique asymptote is y equals 2x minus 1. So if we were to actually graph the original problem, the asymptote function follows 2x minus 1. So if we were to graph 2x minus 1 as well, we'd notice as the values of x get really, really big or really, really small, they'll model 2x minus 1. Moving on to number 22. Use the formula for the sine of the difference of two angles to find the exact value of the sine of x minus 45 degrees. So also from your formula sheet, you might remember that the sine of alpha minus beta, when you subtract two values, and you want a sine value of that, you're going to take the sine of alpha times by the cosine of beta minus the cosine of alpha times by the sine of beta. So what we do here is we define what alpha is and what beta is. In this particular problem, alpha is going to be x and beta is going to be 45 degrees. We don't have to worry about the negative because it's already factored into it with the subtraction. So all we really have to do is substitute in the sine of alpha, the sine of x. You can't really figure that out. There's not enough information to go for it. So all we can do is just say this is the sine of x times by the cosine of beta. The cosine of 45 degrees, you do know that. That's the square root of 2 over 2. So then we're going to subtract the cosine of alpha, and that's just the cosine of x. We can't really do much with that. Times by the sine of beta. And the sine of beta, the sine of 45 degrees, is also a square root of 2 over 2. You might want to write the coefficient first. So this is equal to the square root of 2 over 2 times by the sine of x minus the square root of 2 over 2 times by the cosine of x. And also you might see it written this way if they factor out the square root of 2 over 2. So this would be then the square root of 2 over 2 times by sine of x minus the cosine of x. So there's 3 different ways you might see it. You're responsible for all 3. Number 23, we're looking for an explicit formula for the sequence x, 3x, and so on and so on. So in this one, it looks like you're taking x, you multiply by 3 to get 3x, multiply that by 3 to get 9x. So it looks like you multiply by 3 each time to get the next value. And with that, that means that we're going to be using a geometric sequence rather than an arithmetic sequence. So the geometric sequence is saying that g sub n is equal to g sub 1 times by the common ratio r raised to the n minus 1 power. So g sub n, you do not know what it is, but g sub 1 you do. G sub 1 is the first term, which is x. And then the common ratio, what are you multiplying by each time, is 3. So all you have to do is fill in the gaps and say g sub n is equal to x times 3 to the n minus 1. You might also see it written this way, g sub n is equal to 3 to the n minus 1 times x. And you can always go back through and substitute in, if n is 1, do I get a value out of x? 3 to the n minus 1, 3 to the 1 minus 1, 3 to the 0 is 1, times x, you get x. Test it out for 2. 3 to the 2 minus 1, 2 minus 1 is 1, 3 squared, it's, 3 to the first is 3, 3 times x is 3x. How about the third term? 3 to the 3 minus 1, 3 minus 1 is 2. Now 3 squared is 9, 9 times x is 9x, and that's the third term that you want. So it'll hold true for 27 and 81 as well. So that's what we're looking for. Let's go on to number 24. 24, write the contrapositive of the statement, if I wish upon a star, then my dreams will come true. So this looks like if P, then Q. So where P is I wish upon a star, and Q is my dreams will come true. So it looks like we're kind of feeling Disney-ish on this one. But what we're going to do is say the contrapositive, you switch both P and Q, and you negate both P and Q. So the contrapositive is if not Q, then not P. Going all the way back to chapter 1 with your logic. So if not Q, if my dreams won't come true, if my dreams won't come true, then not P. So P is I wish upon a star, then I did not wish upon a star. So that's what we have by the contrapositive, and we know it's actually logically equivalent to that conditional. So that's 24 for you. In 25, sketch the graphs of y equals e to the x plus 4 and y equals log of x minus 4. So in this particular one, y equals e to the x plus 4, we're going to say it kind of resembles y equals e to the x, but it's really like y minus 4 is equal to e to the x. So y equals e to the x to begin with is that exponential curve that kind of looks something like like this. But if it's y equals e to the x plus the 4, we know it's shifted somehow. And in this particular problem, it's actually going to be shifted up. So it's actually got to be shifted up 4 units. So y equals e to the x plus 4 says we have to shift this guy up 4 units. So it'll look something like this. So that's a little rough sketch of it. To be a little bit more accurate, you would draw some points, pick a couple points out like your intercept, and go from there. For y equals log x minus 4, this is a lot like y equals log of x. And the parent function y equals log of x looks something like this. Kind of like that. It's never going to cross the x-axis, so you can only have positive x values. So if that's your parent function, y equals log of x minus 4, this is going to be the exact same graph, except this time it's going to be shifted down 4 units. So if we shift this down 4 units, it's going to look something more like this. Once again, it will never cross the x-axis. It'll never cross the y-axis. Up here, it'll never cross the y-axis. It will cross the x-axis. It does it right there. It will cross the x-axis eventually, but it will never cross the y-axis. You can only have positive values over here. Alright, so that's 25. Moving on now to 26. And 26, f of x is equal to 2x squared minus 4x plus 6. We're looking for the derivative. So the derivative is f prime of x, and that's saying that we're going to take 2 times 2 is 4, so that's 4x, back the exponent off by 1, and it's 4x. And then minus 4 is still hanging out as a minus 4. Plus 6, that just kind of stays as plus 6, and it's gone. So that's part A. Part B, what's the value of the derivative of the function at the point 2, 6? So at the point 2, 6, we want the x value, f prime of 2, which is equal to 4 times 2 minus 4, which is going to be 4 times 2 is 8. 8 minus 4 is 4. So the value of the derivative there is 4. And then part C, write an equation that represents the tangent line to the graph at the point 2, 6. Well, if you have 4, which is the derivative, which is actually the slope, and you have a point at 2, 6, well, you can figure out point slope form at y minus the y coordinate is equal to slope times x minus the x coordinate. So this is y minus 6 equals 4 times x minus 2, which is technically a correct answer. You can stop right there. If this were a multiple choice problem, it might not give you that. It might give you it in slope-intercept form. If this were a BCR or more of a show your work problem, you could stop right there and get full credit. But just to make sure, if you want to distribute your 4 and then add your 6, you might also see this formula right here, y equals 4x plus 2. Distributing the 4, you get the 4x. You get 4 times a negative 2 is negative 8, plus the 6 is going to be, actually that should be a minus 2, I'm sorry. So we do that, we're ending up with negative 8 plus the 6 is 4x minus 2. So that's why you might want to leave it in terms of point slope form, because you might make a little arithmetic mistake like I did, and therefore it would be counted as wrong, whereas you really got it right. So if there are any questions about that, hopefully you review this and you understand what's going on with that. Moving on to the very last problem, that's number 27. Number 27, there's a handful of parts, number 27. And first up, you're looking for the domain and the range. So the domain to begin with, all the x values. And your restrictions on the x is you cannot divide by 0. So that denominator 4x minus 3 can't be 0. So we're thinking here 4x minus 3 can't be 0. Add 3, divide by 4, and say x cannot be, and that would be a positive 3/4. So your domain are all real numbers that are not 3/4. The range, on the other hand, you're thinking all the y values, but what you really want to do is take a look at the highest power x and the highest power x in both numerator and denominator. And you end up with 12x over 4x. If you divide that out, you just get a 3, which means your range is anything but 3. So all real numbers that are not 3. Part B, write the equations for all vertical, horizontal, oblique, other asymptotes to graph the function. Well, if x can't be 3/4, that looks like some type of asymptote. So that's a vertical asymptote. So vertical asymptote x equals 3/4. If the range is everything but 3, that's also an asymptote. So that's all real numbers that are not 3. For a horizontal asymptote, y equals 3. So that takes care of part B right there. Oblique asymptotes, there are none. If you do the long division, you'll realize that you'll get 3 out as your quotient and not anything with an x. Part C now. Part C, what we want to do is try to figure out the x-intercept, y-intercept of the graph. So if we want to find the y-intercept to begin with, we're going to try to focus on where x is 0. So if you make x 0, this is 12 times 0 plus 1 divided by 4 times 0 minus 3. 0 plus 1 over 0 plus negative 3 is a negative 1/3. So there's the first one, 0, negative 1/3. The second one might be the x-intercept, and that's where y is going to be 0. So the whole thing is 0, so that's 12x plus 1 over 4x minus 3 all equals 0. You could cross multiply and realize you're just going to end up with 12x plus 1 equals 0, or x is negative 1/12. So that ordered pair is going to be at negative 1/12, 0. And the last part that you're asked to do is figure out what the sketch of the graph would be. So if you're trying to figure out a sketch, it might help to sketch out where your asymptotes are. And if your asymptotes have a vertical asymptote at 3/4, so I'm just going to estimate where 3/4 is right about there, and a horizontal asymptote at positive 3, I'm going to estimate that somewhere up there. You also have some intercepts that you can plot, but realize this is a hyperbola, which is your parent function, and the hyperbola is going to model something that looks like this, if you have more of the asymptote there, and something that looks more like, I don't know, this. So a little rough sketch, and that's what we have. And there's your review. Continue to review your notes from the year. Continue to look over these practice problems. The online textbook is still a great use, so if you were still struggling on various chapters, you can go in and look at the chapter reviews and the answers as well. I wish you guys the best of luck. It's been a really nice year, and if I don't talk to you or mention it to you, I will still want you to have a wonderful summer. Good luck, and I'll see you next week.